Hey guys, welcome to another video tutorial. Today's going to be about mp7. I'm going to kind of skip over mp7.1, so today's just going to be about mp7.2 really. mp7.1 is fairly trivial, and I don't think really deserving of a video tutorial like this. So take advantage of it, and get the extra credit. Also, another bit of confusion here for a lot of students is that we call it square maze, but that just actually refers to these individual cells being squares. The maze as a whole can be rectangular. They can obviously be square too, but just don't let that trip you up whenever you start the MP. Okay, so let's get going. Today I'm just going to kind of focus on the cycle detection aspect. So I'm kind of assuming that you already have a strategy for randomly removing walls. But anyway, let's get going with cycle detection. So to start out, to aid our cycle detection, we're going to kind of we want to be able to know if their two nodes are connected. So if we just keep track of which nodes are connected at any time, then it's pretty easy to check if two nodes are connected before we remove a wall. So anyway, we're going to first start out with all the nodes being disconnected. Okay, so we have them down here and they're just sitting there, they're not connected at all. And now we go ahead and get started with our random wall removal. So let's pick this wall, say. Okay, so if we want to remove that wall between 1 and 2, first thing we do is we make sure that 1 is not in the same bucket as 2 is, not in the same set. So if I check here, there's 1, there's 2. They're not in the same set. So I can go ahead and remove that wall. And then I also want to connect them together. So I'm going to let's do this. Okay, so now we have 1 and 2 are connected together. And let's also designate this on the chart here. Okay, so we got 1 and 2 connected. And basically, we keep repeating that pattern with randomly removing walls. Let me do a few more here. So I'll check with 5. And so we got 2 is not the same as 5. So let's remove that. Whoops. Let's remove that wall. Connect them up. Okay, and I'll just do 4 too. Okay, at this point it's been pretty easy. We haven't really hit any cycles yet. But let's suppose for a second that our random algorithm decided to choose to remove that wall there between 1 and 4. Now, if you look here in my structure, 4 and 1 are already part of the same chain. They're part of the same set, bucket, whatever you want to call it. They're part of the same thing. So we actually don't want to remove that wall, because if we did remove the wall, we'd have a cycle like this, right? We could get from 1 to 4 and then back to 1 again. So that's bad. That's what we would like to avoid with this. So since we're keeping track of this data structure here, we know that we should not remove between 1 and 4. So let me go ahead and just finish up this maze for you and show you what a finished maze will look like here. Okay, so at this point there are no cycles in the maze, and there are no more walls that I can remove, because every wall that I would choose would create a cycle. Okay, so great. You guys are looking at this and you're wondering, well, that's not too difficult, but how do I go ahead and implement this? Well, I can't exactly tell you because I make the MP too easy, but think about this drawing that I did here and maybe how it relates to what you guys did for 7.1. And I think, hopefully, you guys will see that it should be pretty easy if you use disjoint sets. So I can tell you how to do it, but go ahead and think about how you can use disjoint sets for cycle detection. And yeah, have fun with it.